All right, so today we're going to talk about SQL and relational databases. So basically, SQL is a relational database. So if you're wondering about like the hierarchy of like what is what, SQL is a relational database. So some very, very surface level definitions. What is a database? Database just stores sets of data. There are different kinds of databases. And we're going to be talking about the two main, well, it's either SQL or not SQL or NoSQL, and that's topic 8, which I will talk about in a couple of weeks. And then something that we won't talk about so much is database management systems. So database management system is basically like, it's usually like a third-party app that you would use. So not through your Jupyter notebook that helps you manage your database. And I'll talk about why in context in a little bit. So within databases, you have relational databases and other kinds of databases. So SQL falls under relational databases. For relational databases, you have relational database management systems. And basically, whenever you have relational database management systems, and when you think of the kind of data that you would use in a relational database management system, it's basically row-based table structures. So I'll talk about this example in a little bit, but anything that you can imagine in data frames, you can usually imagine in relational database structures. In contrast, NoSQL databases or non-relational databases, an example of that would be dictionaries. What we're going to be talking about with topic 8 is MongoDB, and it has a very, very similar structure to dictionaries. So as you know, dictionaries, you have like keys and values. A lot of times when you have very big data sets, you have very nested dictionaries, and it's very, very hard to represent that information in a table in a tabular form. You can imagine there is sometimes like inconsistent number of things nested in a list in a dictionary. That would be hard to put in a table. And that's actually something that we're going to see. I think we're going to see things like that when we get to tomorrow's study group. Just an example. So the system that manages the database, which I mean is good to know for context, but we as data scientists don't work with them as much, basically has the functionality to maintain things like security, accuracy, integrity, consistency of data. That's not really something that data scientists have to worry about, but it's just good to know that, you know, there are these third-party apps and systems that take care of that for us. What data scientists do are mainly Crud functions. So here we have collectively known as Crud functions, basically stands for create, read, update, and delete. And within those 4 operations, the main one that data scientists really use is read operations. So I'll talk a little bit about the others briefly, but today, kind of the more technical work that we're going to talk about is in reading databases. So we have databases, relational databases, and then SQL. So what is SQL? You might have heard it pronounced SQL, doesn't matter. I think it's like whichever you prefer calling it. I know that even at like big companies, people call it SQL or SQL. It basically stands for structured query language, because basically what you're doing with SQL is you're querying data. You're trying to retrieve data. SQL is a programming language that is used to communicate with data stored in an RDBMS, a relational database management system. And SQL is one of the more preferred ones now because it's very similar to the English language. We'll see with some example queries. I mean, it does take a little bit of getting used to, but you know, it actually makes use of English words, which makes it relatively easy to write, read, and interpret. So when working with SQL, I would say that a lot of companies prefer to use SQL, and I'll compare that to pandas. Let's say you have like this giant database, and in pandas, you can have like a bunch of different tables. For those of you that worked on like that superheroes data set, you know, you had a table full of powers and a table full of superheroes. One could argue that, you know, why store things in a database where it's a little bit more opaque? There's actually a database where we're going to look at this SQL database called Pokemon in a little bit. And if I click into this, you can see that, you know, you can't, it's kind of opaque. You don't, it's not like a CSV where you can click and open and see all the values. It's kind of like encoded to be just more efficient. And so that's the one pro that SQL has over pandas. You can, yes, technically do the same thing with a bunch of CSV files and with a bunch of joins and filtering on pandas, but pandas is a lot slower if you were to do the same things. So that is one big pro of using SQL. And SQL is also, SQL is built to be more easily updated. So let's say, you have consistently, you have data that's consistently streaming in, like maybe on like a hourly, daily, basically consistent data that keeps coming in. SQL's update operations are great versus something like pandas, where to update a brand new CSV, if we're doing it through Jupyter Notebook, you would just have to keep exporting brand new CSVs to overwrite. So yeah, those are some slight differences. You could argue like, yeah, you can pretty much do the same thing in pandas, like all of these queries that we're going to talk about later. You can find ways to do them in pandas, but one, data stored in SQL is a lot more efficient. Querying in SQL is more efficient. And also data stored in SQL is also smaller. Like the data files will be smaller than a collection of CSVs. All right. In context of why SQL is important and why it is here in our program, SQL is actually a pretty sizable part of data science technical interviews. Might not think so because, there's just only one topic of SQL here, and SQL doesn't really come back in terms of technical material throughout the rest of the course. But it's very important that data scientists know how to query data. A lot of companies just have databases lying around, and we need to be able to interact with the databases, get the data that we want for analysis. And so our focus is definitely going to be on the reading of data. And I will say, in my experience of interviews, the level of SQL for data scientists doesn't get too advanced. So I think the stuff that we're going to cover today and the stuff that's covered in the phase Canvas material, that should be sufficient to get you through most interviews. As you get closer to graduation next year, I'll send out a bunch more resources. And again, by that time, I think you all will be a little bit more acquainted with coding and a little bit more comfortable with, absorbing new information. So when that time comes around, I will send out a bunch more resources to level up your SQL. One last thing, SQL queries are not too difficult, but it takes a little bit of getting used to. And I think I personally am a big proponent of learning by example. So again, I've mentioned this before. I really like HackerRank. HackerRank is a great resource. If you see on HackerRank here, hopefully, so this was Python, and I showed you all this last time, but they also have a pretty good SQL track. And the SQL track on HackerRank I really like, first of all, because when you're typing in queries, you don't have to do any of the read SQL. You don't have to do like cursor.connect. You can literally just type in, the query itself. And also the series in HackerRank goes it gets incrementally more and more, it builds up. Yeah, that's the word. It builds up on itself. So it's not like they'll throw you really hard questions out of nowhere. They have like a lot of small queries that will slowly build up. And so I think it's a really good series to work through if you just want to, get familiar with SQL. All right, so that's a lot of context surrounding how we use SQL and how we're going to, keep at SQL. One last thing, SQL is definitely something that we can incorporate in all of our projects. Not going to be a priority, especially for the first few projects, but I'll let you all know when that becomes more important. Okay, so as I mentioned earlier, SQL is the SQL files are pretty opaque, right? The fact that, in a CSV, I don't have a CSV here, but this is a JSON file. We're going to talk about JSON files tomorrow. As you can see, we can see this large dictionary. But in contrast, with this SQL database file, you can't really see anything. It's not encoded. It's a lot of just it's just data that we can't read because it is stored in a more efficient way. So therefore, every time you have a SQL database, it should come with a database schema. And this is just an example of a schema. Let me just zoom out a little bit so we can see the whole thing. So this is an example of a schema that talks about, this is a schema about, I'm guessing, just like employees that work in a company. And you see each of these boxes is its own table. So each of these is its own table. So just as an example, like this department employee table has 4 columns: employee number, department number, from date to date, an employees table that has the employee number and all of their information. So each of these is a table. All these lines that connect with each other basically represent the data of which you can join the tables on. So for example, if you have this employee tables and you want to find out, like, their salary information, here we have their salary table. And so if you want to find out what employees were making how much, you can just join the employees table and the salaries table based on, I'm guessing, employee number here. So very similar to what we were talking about with pandas. You can just, there are different ways to do it in pandas, but here you can just say, all right, we're going to join it based on the employee number. So we can see, all right, for each employee, what were their salaries? What's pretty neat about SQL is that, well, I guess it's not really SQL, it's anything to do with like relational databases. You can sort of see from this table here the kind of information that's stored. So you have employee number, their salary, and your to and from date. And so this basically allows you to, store the information of employees having different salaries at different points of time. Maybe they got like a raise every like 6 months, for example. You can have that information there. And then when you join the tables, depending on what kind of join you use, you can have that information all together, like with all of the other employee information. So yeah, every SQL database should come with a database schema like this to just show you, what are the columns that I can even work with. And again, it's because, the database file is just opaque like that. All right, so we already started to allude to what we're going to talk about next, which is relationships. So relationships here is what I think makes a relational database so important. The fact that we can relate, okay, we have a completely separate table of salaries and a completely separate table of employees. We can use that information together. So there are relationships that are defined. And I'm just going to go through like really quickly the kinds of relationships that you have. So there's 3 kinds. I'm not going to zoom. I'll zoom a little bit in, I guess. So there's one-to-one relationships, one-to-many relationships, and many-to-many relationships. And I'll just give quick examples of each one. I feel like these diagrams might not be immediately obvious how they work. So I'm going to use other examples. So first of all, a one-to-one relationship. A one-to-one relationship is basically, one entity in one table has one corresponding value in another table. So in this example, which is not the same as what we had in the schema, each customer can only have one address. That would be a one-to-one relationship. So in a database, and let me see if I don't think there are any examples in this schema here, but let's say in your database, you have in 2 different tables, all the employees or all the customers' information. And then in another table, you have all the customer addresses. So maybe one table, you have like their email addresses, and in another table, you have their like home addresses for like sending orders and stuff. That would be a one-to-one relationship because every customer row in the email address table will correspond to a home address in a home address table. And so that's a one-to-one relationship. If a customer has multiple home addresses, that immediately becomes a one-to-many relationship because one entity in that email address table can be connected to multiple rows in a home address table. And of course, we're going to work through some examples. So I think that'll make it a little easier to see what's going on there. So yeah, I alluded to one-to-many relationship. If like, you have multiple addresses. This is a pretty common example, like a customer for an online store can have multiple orders. So this would be a one-to-many relationship. Just one customer has made multiple orders over the past, I don't know, year or so in the database. One-to-many can include one-to-one. So you have, let's say, 10 different customers. You have a customer that's only made one order, that's fine. If you have a customer that's made 2 orders, that's also fine. You can have a customer that's made 5. You can also have a customer that's made no orders because you have the assumption that they haven't made an order yet. So a one-to-many relationship can be 1-to-1, 1-to-n, or even 1-to-0. So just something that's good to know. It doesn't always have to map to multiple values, because if you just think about it contextually, if you have this database of customers, and if you have like a table of customers and a table of orders, you don't have to have multiple orders per customer. You don't always have to have more than one order per customer. If you were to get like, if you really enjoy like this database work, I have actually taken a class on like databases myself, and they're actually really, really interesting ways of finding like, all right, redundancy and also dependencies within databases. And I would say, yeah, if you're particularly interested in databases, not right now, but after graduation, I will link you all to a bunch of like resources if you want to read up more about it. Finally, we have many-to-many relationships. Here it gets a little more confusing. The whole idea is if you have a table that has all sorts of orders, and if you have a table with, just your inventory of items, the idea here is that an order can have multiple items, and an item can be a part of multiple orders. And so that's a many-to-many relationship. Becomes kind of complex as you're doing like your table joins, and your tables usually end up being very big, but it's a relationship that does exist in the real world. Typically with this kind of relationship, you might see something called a junction table or a join table. And so there's actually an example in this schema here. We have departments and then we have employees. If you think about it, employees can belong to different departments, and then, employees can belong to different departments and maybe at different points of time, because you can see there's from date and to date. And also departments can have multiple employees. I forget which way I said it the first time, but basically same thing. Departments can have multiple employees. Employees can be part of different departments. So therefore you have this many-to-many relationship that, to make your joins a little bit cleaner, they actually have this middle table here called, I guess, department employee, that serves as a join between the two. And so this junction table, there are many names for this table. I call it a junction table. It allows you to store information about the specific relationship. So a particular row in department employee is going to show you, all right, well, there's this particular relationship, like this employee was in this department from this date to this date. And so it just allows you to store more information about the relationship specifically. Cool. Any questions about this so far? All right. Why this is important for SQL is because usually in databases, you do have multiple tables. So it's important to, especially as you're making your joins, it will become more obvious later on. But just being aware of, okay, what kind of relationships exist in my database will help you, one, also like quality control your results. And yeah, a lot of these things, it's important to think about it in context. So, with orders and items, you just think logically, items can be in multiple orders can have multiple items. So I think it's easier to think about it that way. Okay, let's zoom back in. In SQL, we have data types. If you remember when we were getting into pandas, pandas has its own D types as well, right? We had like our integer, and pandas does like int 64, float 64, which still means integer and floats. And instead of strings, they're objects. With SQL, it's a little bit inconsistent. So I don't know if anyone has heard of like the fact that there are different kinds of SQL that exist out in the world. So the one that we're going to play around with today is called, it's a specific flavor of SQL known as Sqlite. Some of the more common other forms of SQL, there's MySQL, there is PostgreSQL, there's Oracle SQL. And so these SQLs, in terms of the queries and how they're structured, pretty similar, but there are always slight syntax differences. I would say it's not a big deal if you like learn one kind of SQL and a company asks you about another kind. It's usually pretty easy to just adjust because it's sometimes like, a different phrase is used, maybe like one method instead of being used this way, you have to use it a different way, stuff like that. I think the whole concept behind querying is still the same for all of the SQL flavors. So when we get to data types, that's where some of the inconsistencies arise. So you'll see in the schema, and so in this schema here, we actually had the data type. So here we had int 11, char 4, date, varchar 14, varchar 16. The number in parentheses is basically how many digits or how many characters it can have. I actually recently learned this, but this basically helps your database allocate the right amount of space. It helps your database allocate the right amount of space in memory. So that's why that is there. So literally like int 11 when you set up your database, it will, set aside like 11 space for up to 11 characters for each entry in your database. So that's why that is important to know. So if you know that employee number is always going to be like an 11-digit number, set it as 11. If you think, it's only up to like 4 digits, set it as 4. So yeah, things to note. Varchar stands for variable character, and it's basically like strings. And I know that in different flavors of SQL, sometimes it's called varchar, sometimes it's called text, sometimes it's called, I think sometimes it's called string as well. Yeah, sometimes it's called string. Char is also the same as varchar. I actually am not sure what the difference between char and varchar are. But I think it's like one is a subset of the other, but I don't think that's super important. Cool. So these are all just like the different kinds of data that can exist in SQL. I guess, yeah, the difference between char and varchar is maybe, nope. Yeah, never mind. The one that we're going to focus on and the ones that, the flavor of SQL that is in our labs is Sqlite. So Sqlite is a little bit more straightforward. There are not as many data types. These are the main ones. There are still more than these 5. But the main types are, instead of, varchar and char, it's text. Numeric is also a data type that you can use that includes both floats and integers. You can have integer, you can have real, being a real number, and blob. Blob is funny because blob basically means that, all right, if you have a data field that is like a long chunk of text, it's called blob. So these are just good things to know. In terms of data types, why it's important for us to know is if you wanted to maybe have a condition, sometimes it matters what data type it is. So for example, if you want to sort your numbers, or you only want to query like a field of like numbers that are greater than 0, for example, you need to know if the 0 is stored as a string or stored as a float or a number in order to correctly make the comparison. Because sometimes you even run into like integer and float comparison errors, depending on the flavor of SQL, honestly. So yeah, something that's also good to remember, if you're trying to debug your SQL, when you're Googling it, mention what flavor of SQL you're using. And for this program, we mainly are using Sqlite. All right, before we get into examples, any questions? Okay, so this is going to be a very, very quick intro to SQL. I would say the best way to learn SQL is through practice. So we're going to play around this fairly simple SQL database. It's about Pokemon. I don't know if any of you are fan. I'm a big Pokemon fan. I used to play all the games, still do sometimes. But these are the 3 tables we have. So we have a Pokemon table that has a bunch of Pokemon, their name, height, their ID, weight, their base experience points. You also have their types, like what kind of types the Pokemon are, right? So you have ID and name, and we'll take a look and see what that looks like as well. And then we have this Pokemon types table, and we'll see in a little bit why we have this 3rd table here. In Jupyter Notebook, I think before the recording, Nelson asked about the different ways to query SQL within Python or within Jupyter. there are several ways to do it. Here we're going to use pandas because pandas has a built-in read SQL method that I personally prefer that one. You'll see that there are other like cursor methods. They all kind of work the same way. So to begin, we have to first connect to the database file. Similar to when we're doing like pd.read CSV, you just need to tell your Jupyter notebook, where do I send this query to get information? And so to do that, just sqlite3.connect and then give it the database file. And as you can see here, I have the database file in this is my desktop actually, and it is right here. All right, so let's take a look at our tables to start. And while doing that, talk a little bit about syntax. So specifically for pandas read SQL, it's been a lot of trial and error in figuring out, what kind of syntax works, especially for quotes. Because as you can see here, this is our SQL query. I have found that it's good to be consistent in whether you wrap your SQL queries in single or double quotes. And where you run into some issues is, let's say you want to have a condition where you want to check for a certain string. If you have another string in here and you also wrap it in single quotes, it kind of throws off your string because it doesn't know where it starts and where it ends. So if you have a string within your query, wrap that in double quotes. And then your whole query is in single quotes. So just remember that with syntax. Let's start with the most basic query, a select statement. And as you can see here, the way that you structure a select statement, and select statement is really just like the backbone of any SQL query. You're selecting something, and star means all from something. And the from usually the from has to refer to a table. So this database has a name. The database's name is Pokemon.db. And within this database, there are 3 tables, Pokemon types and Pokemon underscore types. And so when you're doing a from statement, every time you use from, it has to then refer to one of the tables. So let's just start with the first one. Select star from Pokemon. And because it's a pandas function, it really nicely returns a pandas data frame. So as you all know, we like pandas data frames. So this basically has just selected everything from the Pokemon table. So we have all of our information here. Great. And so you can see there is 151 Pokemon, and this is all their info. The next one we'll look at real quick is types. There was this types table here. And if you are familiar with Pokemon, there's not too many types. I think there's I want to say 20. No, so there are 18 different types. And imagine if I wanted to put the types with the Pokemon table, it can get a little bit inconsistent because of the many-to-many relationship. So if you think about, let me just do this real quick. If you think about, okay, let's say I wanted to store the types with Pokemon. So the tricky part is Pokemon can have multiple types. As an example, let's say you had I don't know, a Pokemon that was both associated with, what's an example? Maybe flying and poison Pokemon. Storing that here would be hard because then let's say, just as an example, let's say Bulbasaur is a grass and poison Pokemon. You would have to have 2 rows of Bulbasaur and then you have redundant data. So because of that many-to-many relationship, we need to have that middle table. So that's why we have this third table, Pokemon types, that sort of just matches the type ID with the Pokemon ID. So this is just a quick way of representing that many-to-many relationship. And this will come in handy in a little bit. Okay. We're going to go through this fairly quickly. Definitely through me talking about this is not going to oh yeah, okay, I know how to do SQL queries now. It's just really to just go through what the main parts of most SQL queries are. So we talked about this one first, select from. So what columns are we selecting from which table? So if we're selecting everything, and this is the same as what we had before, we're selecting all from Pokemon. If I wanted to select specific columns, I can do that here. So instead of star, I would just replace it with maybe like name and base experience. And that would return me only the 2 columns. So I just want to like reiterate that, yes, we can do the same thing in pandas as well, but it would be a lot less efficient in terms of the coding and also in terms of the computation time to do this in pandas, because SQL has been optimized for doing all of these operations faster. So yeah, just a select statement is just if you want to take a subset of columns. Note that this is a subset of columns. If you want to do subset of rows, that's what we're going to talk about next. So we have select and from statements. Next, we're going to talk about where statements. And the way that SQL statements are built, it's really kind of like modular. You just add the parts that you need. So next thing we're going to talk about is where clauses. So this is an example. Let's find all the rows from the Pokemon types table where the type ID is 3. So, okay, a couple things here. They're saying that finding rows from the Pokemon types table. So when I'm constructing my query, I know what I'm going to do from Pokemon types. And then I'm going to have a filter condition where the type ID is 3. And it kind of reads like English. So all I'm doing is where type ID equal to 3. So if I run this, yes, if you remember the Pokemon types table, it was just the IDs. But these are all the Pokemon that have type 3. At this point, I would also like to point out that you can see here that I'm using all caps for any like keyword, but know that SQL is actually not case sensitive. It's only case sensitive if you're like doing a string in a condition, then yes, that is case sensitive. But like in terms of in your query, it is not case sensitive. I can have this all lowercase and everything will still work. I personally like to do all caps just so I can see where my keywords are. So this is a where clause. The next thing we're going to add on to this is, let me see, are we doing this in the next one? Yeah. So the next thing we're going to do is joining. So join works very, very similar to the way that we did joins in pandas data frames. So we're going to see something kind of similar. Let's see what this prompt is. Let me just put this in multiple rows so that we can have it. All right. So find all the rows from Pokemon types table where the associated type is water. So you're getting all the rows from the Pokemon types table. So we're going to really build this up. And let me actually do this. This is a good trick to learn in Python. If you ever have like a line that was far too long, if you want to break that line up into multiple lines, you use a backslash and it would just recognize it as, okay, just continue on to the next line. So here, what we're doing is I'm doing the select Pokemon types from Pokemon types. Oh, here, where this is slightly different is because I'm selecting all of the columns from the Pokemon types table. Why I have to say table.columns is because I'm joining tables now. So here, if you remember the Pokemon types table only has numbers. I don't know what number 3 refers to. And here they're saying the associated type is water. So here we're going to join the types. We're going to join the types table. So let me just actually do this part by part so we can see what's going on. Here, let's comment this out for now. Oops. Okay, there we go. Let's comment this out for now just so we can see like how it builds up. Okay. So here we have our, oh, let me just get rid of this as well. Okay. So if I didn't specify, I wanted just all the columns from one table, it's going to give me all the columns from all the tables that I've joined together. So as you can see here, I have the first, I have the Pokemon types table, which had Pokemon ID and type ID. And then as you can see here, I have an ID column and a name column. So these are the columns that have been joined together. I have the, this table basically is all the information from the types table that literally just had type ID, what's the name of the type. As you can see here, these 2 columns match up because these are the 2 columns that are being joined on. So this is what it looks like at this point. And at this point, all I have to do is just filter for the water types. So to do that, I just add that where clause. That should work. And as you can see here, when I'm using when I'm conditioning on a string, I have to use double quotes within the query. When I do this, I have all my water types. More specifically, because it said you want all the rows from Pokemon types, that's when I do Pokemon types dot star. So I'll have all of these. Maybe I want to get a different subset. I can do that too. If you have multiple tables, when you're calling on your columns, it's a good practice to say, all right, from this table, this column, because sometimes you have overlapping names across two tables. So let's just say I want to do Pokemon ID from this table. Let's say I want to get types dot, is it types dot name? Yeah. Actually, let's do Pokemon name. Or is it just name? Yeah. You can see here, it also throws you errors. Let's do this. Oh, that's what I meant to do. Let's just see what that is real quick. Okay, we don't have the Pokemon name yet. That's why. Let's see, what are we doing? There we go. Okay, so now we have these Pokemon IDs and the type's name. Something else that you can do within SQL is you can alias things. So for example, now with this result, this name column is not very indicative of what it is. So something else that you can do is when you're selecting these two columns, let's say I want to change the name of this column in my result. I can do types.name as type. When I do that, it changes the name of the column into type. Cool. All right. The next one we're going to talk about is aggregation and group bys. So let's go back up here. Group bys is also something that we did in something that we also did in pandas. So we have group bys, and usually when you have a group by, you also have having. So I'll talk about what having is in a little bit. So if you remember, group by is whenever you want to aggregate something within like categories. And so that's what we're going to do here. So what we're going to do is we're going to find the average weight for each type. And just as an additional thing, what we're going to do is we are going to order the results from highest weight to lowest weight, and then display the type name next to the average weight. So let's build this query together. Let's see. So because of the information that we're using, we're going to actually join a bunch of things, and this query is going to get pretty long. All right. So a couple things that we're doing. First, when I'm constructing like a complicated query like this, I think about which tables am I going to use. So because I want the type name and I want the like average weight, if I go back and look at my schema and think about, okay, I need to use the weight, which is here. I need the type name, which is here. I'm pretty much going to use these three tables because this table is how I connect this table with this table. So at some point, I'm going to have to join all of my tables together. If I'm querying from one table, I'm going to have two join statements to join my other two tables. That's what we're going to do. So we'll get back to this in a little bit, but I like to start with the joins. First, I'm deciding that, okay, I'm just going to query from Pokemon. There are actually different ways to structure this query. You can actually have your base table be one of the other tables, which is pretty neat. But in this case, I just decided to do it from Pokemon. Next, I'm going to do my joins. I'm just doing inner joins for now. This is something that I honestly just trial and error a little bit, but I'm telling it to join the Pokemon types table based on these conditions. So I'm doing Pokemon types.Pokemon ID has to be the same as Pokemon ID. And then I'm also going to join the types table, similar thing. So to have those joins together, I'm going to do my group by. When I do my group by, I know because I want to aggregate within each type. That's why I'm grouping by types dot name, the name of the type. And similar to pandas, whenever I do a group by, it has to come with an aggregation. It has to come with like, yeah, it has to have some sort of summary statistic for each group. And the kind of tricky part with SQL is you actually tell it what the aggregation is at the very beginning. So as you can see here, when I'm selecting, I'm actually selecting the average weight. So that's where the aggregation comes back in. And here I'm just choosing to select the average weight and then the name of the type. And then this, just a little extra thing, if I want to just arrange it in a certain order, I know that in pandas it's called sort values. Here it's called order by. And then here you're just ordering it by the average weight and descending. So that's how I end up with this. So you can see that basically ghost type Pokemon are the lightest ones, and then ice type Pokemon are the heaviest. This is really to show that queries can get pretty complex. Here I'm using 3 tables all together, and I'm doing an aggregation. Okay. Next up, we're going to do find the names and IDs of Pokemon that have more than one type. So, okay, we want to see what Pokemon have more than one type. What information are we going to use? So if we look back at our schema, we need the Pokemon, and then we probably need their Pokemon types. Do we need this table? Because this table, the new information that this table is bringing us is the name of the type. And we don't really need the name of the type. We just need to know how many there are. Less important for now. So let's just start with, okay, we just need these 2 tables and we see how we do. Okay. Back down here. Let me just put this into multiple rows so it's easier to see. Okay. So again, I personally like to start with the joins. So here we're joining our Pokemon types on, the same thing that we joined the junction table with before. And here we're just saying, okay, I want to select these columns, my Pokemon ID and Pokemon.name, because it says names and IDs of Pokemon that have more than one type. Here I'm doing my group by because I want to count which Pokemon have more than one type. And so that's what I'm doing here. And the aggregation I'm using here is count. So one thing that I'm going to show you all as well is if I were to include this here and rerun, I actually have my count here. Something that's pretty neat is that, yes, I have this condition, and I'll get to like why we're using the word having instead of the word where, because that's what we talked about earlier. Even though we have this condition, the result of a SQL query doesn't have to include the column that you're doing the condition on. So I like to think of the SQL query as, yeah, it's pretty much doing all of this other stuff first, and then selecting which columns to return as your result. Hopefully that makes sense. But anyways, something that's interesting about the having statement, and when you're dealing with filtering a group by clause, when you're filtering based on an aggregation, you have to use a having statement instead of a where statement. I don't know why that's the case, but that's just how it is. Whenever you are filtering or doing a condition based on, you're doing a condition on a group by or an aggregation, you just have to do a having statement. So that's why here, instead of doing where count equals to more than one, you have to do having count is more than one. Just something to note. It's actually come up as an interview question for me once as well. Like, what's the difference between using a where and using a having? And the answer to that is just when you're doing an aggregate, if your condition is on the aggregation, you have to use a having statement. So yeah, in this case, this question didn't ask for the count column, but you can just know that that's there. Okay, one last one that might look a little bit different. The question is, find the ID of the type that has the most Pokemon. So this is something that's a slightly different because of instead of returning, rows from a table, we're just returning like an aggregation purely. And so we're finding the ID of the type that's the most Pokemon and display that type ID next to the number of Pokemon having that type. So here, let me just again split this into multiple rows. Here, because they're not really asking for the name of anything, I figure that, all right, I pretty much just need to be able to count the values. I can pretty much just go off that middle junction table. So that's why I'm just doing from Pokemon types. And then I know that I want to find the type that has the most Pokemon. So I'm grouping by type ID. And I have that with my aggregation of count Pokemon ID. And then here is where we have something different. Let me just comment this out. Here we go. So before I do all this other stuff, if I'm doing just this aggregation of group by type and then also count a Pokemon ID, you can see that we have this. We have all of the different type IDs and then also the number of Pokemon associated with each type. The next step we're going to do is we're going to find the one that has the most Pokemon. So that's what we're going to do here. And that's what this next part is doing. All we're doing here is we are arranging it by the number of Pokemon descending. So that's just going to arrange this column high to low. And then limit 1 is sort of like the dot head in pandas. So if I run this real quick, it's just going to take the first row. If I do like limit 5, it's going to take the first 5 rows. That's something that's also pretty good to know. I know I went through this pretty quickly, but I think that these are the main things to be aware of with SQL in terms of, the keywords that you're going to be using to construct your queries. Highly, highly recommend, maybe not now, but definitely before you start your job search, to just practice a lot of SQL. I admit that, when I'm teaching these cohorts, there will be like a good number of months that I don't touch SQL at all. I will forget a lot of SQL. So it's definitely something that I will make the effort every few months to go back and make sure that I remember how to query in SQL. But yeah, I recognize that was like a lot of information being thrown at you all. Does anyone have any questions about anything that we talked about? All right, very good. I wanted to talk about the schedule for the next couple of weeks. So tomorrow we're skipping topic 8 and we're going straight to topic 9, just because I think it's just more relevant. And then next week on Tuesday, I'm actually getting my vaccination. So because of that, I've moved our study groups to Wednesday, Thursday. So sorry in advance for any of the inconvenience caused. On Thursday, what that study group will be, instead of doing topic 8, I'm going to be introducing the project. So that one is not as important to like be present, I guess. So I'm just it will be recorded. I'll introduce, the project requirements, things to be thinking about and things that you might want to brush up on before working on the project. And then as you can see here, that's next week, phase 1, week 6. Week 7 and 8 will be you guys working on the project. The first study group on week 7 will be going back to topic 8, but these other study group slots will be for office hours. And each office hour is not really like, it's not always, most of my office hours are not just like open, ask me questions office hours. I mean, there will definitely be time allocated for just asking questions during these sessions, but most office hours, I actually do have like a mini topic to talk about that's pertaining to your project. So yeah. The way that projects work, and I'll get into that a little bit more, is you are going to have like a project presentation day. So as you all saw, or maybe some of you saw that yesterday, my other cohort presented their capstone project. So every phase they had like a presentation of their projects, and yours will be phase 2, week 1. It will be the first study group. It'll be project presentation. So just prepare for that. And I will also like some of the office hours that I'll be giving will prepare you for giving these presentations. So that's just what to expect for the next couple of weeks. It's already towards the end of phase 1, which is pretty crazy. Something else I'm going to do, I'm also going to be sending out a survey to the Slack channel that is collecting feedback on the lecture videos. I know some of you have been using the lecture videos. If you haven't, then don't worry about it. But because I had mentioned that these lecture videos are something that Flatiron School is working on, we would love to hear any of your feedback if you have any. So I'm going to be sending that out with this recording when I post it in the Slack channel. Sweet. Any questions or comments for today?
Okay, I have some like, I don't want to say it's not related to what we went over today, but kind of like just curiosity questions.
Yeah, go
So I
ahead.
have a few written down. So from your experience when you did like your contract work, did you have like, do data scientists ever do like, are they ever tasked with like researching data points and then kind of creating new, what's the word? Running like an analysis and running like, I guess, getting test data to then implement that into like a database at like a company. So let's say like they were looking for more measures to, let's say, get better predictions about something. And they were like, oh, well, we want you to kind of explore, give us like, find like a test data set, run an analysis, and then put that in. Do you ever find that happening? Or is that kind of like a data engineer or outside of data science?
In my personal experience, it's kind of been like a collaborative effort. I've only really worked in places where I was a data scientist or machine learning engineer, and then there is a data engineer that, like, we work together. I would say, like, for my analysis, I kind of would like this data to be collected. Can we like set up the database to collect that information? And then they would do that for me. I can imagine, yeah, there might be scenarios where you might do that. Again, not the most important thing for data scientists, but it's a good thing to also familiarize yourself with, and this information will actually be shared with you all after graduation. We have kind of like a mini post-graduation curriculum. And on that, there's like more advanced SQL where it can actually show you how to create tables and like insert new data. I'll actually talk about that. Yeah, I actually do like a capstone study group on that as well. So it's definitely good to know. It's definitely possible. I would say not the majority of the work done, but yes, definitely possible that you might have to make changes to a database and implement changes in a database. I would say it's not too difficult. It's just, if anything, a little finicky. But yeah.
Okay. And then we're going to talk about JSON later, right? So I was asked a question about JSON and like how it's stored.
JSON is tomorrow.
Okay. All right. All right. I'll save it for tomorrow. All right. That's it.
Awesome. Anything else? Cool. Or if there's nothing else, I will see you all tomorrow. Tomorrow, don't forget, we're going to be talking about JSONs and APIs. I would say if any topic is being incorporated into the project from like 7, 8, 9, 10, it usually is like the JSON API section, just because it's a really good way to augment the data set that we provide for your project. So just preview. All right, then. Well, if there are no other questions, as usual, Slack me if you have anything. And if not, I will see you all tomorrow.
Thank you very much.
Bye, everybody.
Yes.
All right.